Okay, good afternoon. That was energetic. Ooh. Can you take a picture with me anytime? So that's a very, very large crowd, but I'm not going to take a picture so that people don't know how large this crowd is. In my next talk, you have no choice. I'm the only person, so you're going to have to come. So generally, I was actually talking to Michael on the way here today, and we were talking about the back history of this conference and how it kind of came from .NET. Are the majority of you here .NET developers? Yeah. Yes? Anyone that does Java? In high school? They don't do Java in high school anymore. They do Haskell. What about JavaScript? And enjoying it? Always a few, aren't there? Okay, so I'm going to show you a new language then, I guess, because how many of you have heard of Kotlin and use it? Okay, cool. 2 people. Excellent. So I'm going to show you a little bit about Kotlin, but it's not going to dive too much into the language because this is kind of like giving you an idea of the history of Kotlin and what you can potentially do with it today. So to give you some history, we started Kotlin in 2010 at JetBrains, we being JetBrains. We started Kotlin in 2010. Why? Because we were bored. And also because we wanted a new language to work with, because we were writing the majority of our tools using Java, and Java isn't the most concise language in the world. And we wanted something that was a little bit more modern, something toolable, etc. And our options there were Scala primarily and Ceylon. And for different reasons that I won't get into, we decided not to go with either of them. So here we are, 9 years later, with Kotlin. Now in 2010, we started Kotlin on the JVM because that's what we're doing, right? Most of our tools are based on the JVM. The server-side tools, all of our IDEs are based on the JVM. And then we've got the .NET side, which is mostly C#, F#, because somebody's got to use it, and VB, again, because we do tooling for VB.NET, so we need to do some dog fooding. And we wanted to make it interoperable with Java. That was one of the main things. Like, we couldn't close shop and say, okay, for the next 5 or 6 years, we're going to basically just rewrite everything with a new language. We needed to leverage everything that we had, and everything we had was on the JVM. So it had to be completely interoperable. And we want targeting server and desktop applications. In fact, at no point were we ever targeting mobile applications. People say, oh, Kotlin is an Android language. No, it's not. It initially even wasn't an Android language. It only became popular because somebody said, can it work? It wasn't working. We fixed it, and then it started to become popular, and then Google adopted it, and now it's an official and first selected language of Google for mobile development. But Kotlin has never been mobile only. In 2012, we decided to expand, and we came up with Kotlin for JavaScript. Why? Because everyone was doing it, and we thought, well, we can do it as well. And generally because we wanted to write some JavaScript applications, and we weren't really happy with the state of JavaScript, so we decided to do Kotlin for JavaScript as well. Again, the same thing. Leverage what's existing on the platform. Do not reinvent the wheel. Make it interoperable with all of the libraries. Make it interoperable with the language. So that was, once again, a constraint that we had. And what kind of what kind of applications did we want to target? We wanted to target web applications, meaning browser-style applications, and node or server-side applications. We also decided to go with Kotlin scripting. And Kotlin scripting was the idea that you could write scripts. That's why it's called Kotlin scripting. And you could host scripts. So instead of using languages such as YAML, well, YAML isn't even language, is it? I mean, YAML is as much as a language as JSON is, probably. We decided to have a more fully fledged scripting language which allowed you to do certain scripting for different types of applications. Usages of this would be, for example, build script. How many of you use TeamCity? Yes, so we use Kotlin for TeamCity. Test scripts, spec, command line utilities, routing scripts. So there's a web server, there's a server-side and client-side technology that we've created which is called Ktor, K-T-O-R, which is kind of similar to Spring. And or similar to in your world would be not Sinatra. What was the Nancy? I think. Have anyone heard of Nancy? Yeah. So Ktor is kind of like Nancy. all based on kind of the same idea of Sinatra Express.js. Type-safe configuration files such as TeamCity, REPLs, and consoles for data science. Kotlin is starting to take off in data science as well. In 2017, we went even further and we decided to do Kotlin native. So that means that now you can start to target any platforms as the ones below, which is iOS, macOS, Android, four squares, a penguin, and if at some point WebAssembly arrives, then we'll look at improving WebAssembly support. That is essentially what Kotlin Native allows you to do. And Kotlin Native is basically, right now we announced it as beta in 2018. I think it was last November or so, October. It's not released yet, but that's the type of platforms. Anything that LLVM can target, Native can target. Once again, we tried to make it leverage the existing stuff. So interoperable with C, with Objective-C, and with Swift. So if you're using iOS, you can interop with Objective-C or Swift. If you're using things like C libraries, you can interop with it. C++ is not interoperable with. And I think it was Strootstrup who said that even C++ isn't interoperable with C++. Types of applications you can develop here. Mobile applications, obviously if I'm targeting iOS or Android native. Desktop, systems, embedded, Raspberry Pis, anything you can essentially think of. The way that it works is that it's using LLVM to target the multiple platforms. So we're basically emitting an intermediate representation language that then uses LLVM as a backend to target all of these different platforms. It provides you with runtime guarantees such as exceptions, memory management. It provides you with standard and multi-platform libraries. So Kotlin in itself, the surface area of the language is very, very small. The way we've designed it is to make it quite extensible, quote unquote extensible, by creating functions and libraries. So a lot of the things that you may see in Kotlin may feel like they're keywords or part of the language, but in fact they are not. They're just basically functions as part of different libraries. If you're familiar with async await in C#, which I'm sure you are, async await is basically built into the language in C#. In Kotlin, it's just libraries, library functions. And yet when you look at it, it looks exactly as if it were built into the language. So we offer standard libraries for Kotlin, and now if you are targeting Java, JavaScript, native, that standard library is available on all platforms. In addition to that, then we offer multi-platform libraries, where it is now I'm going to create, for example, a socket library that is available for JavaScript, for native, and for JVM. And it's not only us. There's a whole bunch of companies that are working on this. Square, for instance, those people that do payment processing, they're working on a bunch of multi-platform libraries around Kotlin as well. So platform libraries such as POSIX, Apple Frameworks, Win32, COM, etc. DOM. The way that it works, you take Kotlin source code, you put it through the compiler, which is the part that we developed, the front end in compiler technology terms, and then that emits intermediate representation that gets pumped into the LLVM backend, and that is the one that generates the platform binary. In terms of memory management, so now we go from a system where we're all familiar with garbage collection and we don't really have to worry about anything about freeing pointers and things like that. Anybody did anything in C or C++ or Delphi or anything like that? Yeah, Delphi? Wow, quite a few. So in Delphi, remember, we used to do free and then a nil, and then one day we got free and nil, so we only did it in one call. We don't do that anymore, right? We don't care about the garbage. Someone else recycles it for us. It's kind of like the things that I saw today in the Munich airport, right? It went from you having to recycle everything to now just one bin that says we'll do it for you. So how do we do this in a non-managed world such as Kotlin Native? We have the concept of arc with cycle collector. So arc is automatic reference counting. So essentially it's going to count the number of references to an object, and once that reaches 0, then it will dispose of that object. That type of memory management comes with its own kind of issues, one of them being cycles, where you have object A pointing to object B and then object B pointing to object A, and what happens is that becomes cyclical and potentially leading to memory leaks. Now, the way that many languages try to approach that is by weak references, which means that when you have a weak reference that's pointing to another object, if the only thing pointing to it is that weak reference, you can get rid of it. We also have the concept of weak references in Kotlin Native. However, we also have the cycle collector, meaning that it will try and detect those cycles and free that memory. When working with pure Kotlin, though, you don't really have to worry about memory. And I'll put that in under quotes because there are certain things that you do need to be aware of. When you are working with non-Kotlin, you do need to worry about freeing pointers, etc. Now, what about this scenario here, which is shared plus mutable? Okay, this is the biggest, worst scenario ever. Shared memory is fine as long as it's read-only. When it's mutable, it's when it becomes a problem. So what we try and do with Kotlin Native is not allow you to do this. Meaning that if you have shared memory access that you're trying to write to, it's not going to allow you to do it. It will give you a runtime exception. This has its caveat in that potentially the same type of memory access that you would do with Kotlin targeting the JVM may give you a runtime exception when you're targeting Kotlin Native. So it's still something that we're working on, getting feedback and seeing what we do there. But targeting multiple platforms needs more. You don't just say, okay, I've got this language and I can now target all of these platforms. You need to be able to share code. Because if you do any kind of mobile development, for instance, if you do Android and iOS, a lot of you are ending up having to repeat the same code over and over again. So are you familiar with solutions such as React Native? Yes? You're familiar with something like Xamarin? Yes? Flutter? Yeah? So everything they do, we don't. We do it completely different. I won't tell you how, but we just do it different. Now, the way that we do it is we basically have this idea of common code. So if I'm targeting the server, I'm targeting Android, I'm targeting iOS, I'm targeting the browser, I have some common code. And that common code is business logic. But business logic isn't just business. Business logic can be a whole bunch of things. It could be memory access logging. It could be authentication. It could be a whole bunch of things that essentially is the same over and over again on different platforms. This is the idea of I can share this code and then on each platform delegate to the specifics of that platform. So if you are writing a multi-platform project in Kotlin targeting Android and iOS, in Android you would target Android JVM. On iOS, you would target Kotlin Native with output interoperating with Swift and iOS and Objective-C, but you would use the primitives of that platform. We don't have our own set of UI. You basically use what is available on that platform. So here, for example, I have some common Kotlin code. I have the JVM, I have JavaScript, I have native. And then that also introduces another issue, which is sometimes that code may vary slightly. It may vary that I have a function that I want to call, just like an interface that you want to call, and then the implementation may vary. But in the common code, I want to be able to refer to that code. So essentially think of interface and implementation. So in Kotlin, the way we do that is with two constructs, which is called expect and actual. So expect essentially saying expect some declaration, something to exist, and actual is saying it will exist at runtime. And I'll show you examples of this in code later on. So this allows you to now have common code that is actually having different implementations on different platforms and yet using it in the larger common code base. In addition, as I mentioned, we're working on the multi-platform libraries. We've already got a bunch of this already done, not only us, but the community. There's a whole bunch of multi-platform libraries that are available. So now if you target Kotlin with multiple platforms, you don't have to reinvent the wheel with all of this. And then on each platform, you interop with the existing libraries and ecosystem that exist. Okay, so with that, I'm going to switch over and show you some code. Any questions? Nothing? Okay. How many of you actually seen Kotlin code before? Like 4 people, no? Everyone does C# here? No? Okay. So I'll give you a quick, like a very, very quick intro to Kotlin as a language so that we're all kind of on the same page. Okay, so I'm just going to create a default Gradle project, and then I'm going to come here and I'm going to say directory, we're going to say Kotlin And I don't need to create a Kotlin directory, but I'm going to and say ABC or main, right? And I should have named that. Oh, go away. Let's remove that. This should be source. Mark directory as sources, and then we're going to do new Kotlin main. Okay? Oh, go away. I said it's configured. Okay. So now I have main. So that's my main function. You can see that all nicely now. Good font size. Okay, so that's Kotlin. Any questions? That's the main entry point to your Kotlin application. You don't really need to know more. If you want to print hello, hello world, and then you just run it. Usually this works, except when I do it. So Kotlin basically has, it's a so that you kind of get where we are coming. Kotlin is, Kotlin is configured. Never mind, let's just go back here. There's some Kotlin for you. Let me just open up a main. Font, Kotlin, main, print, main, print line, hello. Okay? There. That will run, and that's Kotlin. Now, Kotlin is an object-oriented programming language with functional constructs. Unless, of course, I'm speaking to an audience that is, by and large, functional programmers, in which case Kotlin is a functional programming language with object-oriented constructs. So, but it is kind of true. Kotlin basically has classes, it has interfaces, it has all of these things that you would come to expect in C# or Java or everything, but it also has top-level functions. So it's essentially like JavaScript, but in a very, very, very good way. So here you can see that I have basically my main function, which is essentially my entry point. This would be the equivalent to public static void main blah, 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 and that would be the entry point of your application. I don't need to have a class. I could just have a top-level function. And I can have another function. So we have some cool things like, for instance, if I want to write sum, we use Pascal notation. So x, y equals int, and then I could say return x plus y. That would be a sum function. And then I could just basically call this. It has all of the optional arguments and all of these things that you've come to expect. But I could write this even shorter in what's called single expression functions, which is essentially the same as doing that, right? So that is basically the same thing because it's very big on type inference. It's statically typed, but it's big on type inference. So this is essentially saying that the compiler can infer that the return type is int, and then it's an x plus y. Okay? And then it's got some much cooler shortcuts. So for example, if you're familiar with extension functions, extension methods in C#, you know that you have to create a class and then a static and then pass this as the parameter, etc. If I want to do, for example, to camel case in Kotlin, all I do is just write the type, a dot, and then the function I want to extend it with. So now any string in Kotlin, ABC, has to camel case. Okay? So it's got extension functions, it's got extension properties, it's got a whole bunch of things that you come to expect in a normal language nowadays. And of course we have higher order functions. So a function higher order, and then I have f, so that takes, for example, no parameters, and it returns a unit. Now unit is exactly the same as void, except it's completely different to void. Unit in Kotlin is an object. So just like in JavaScript, you have objects, and you just have objects, you don't have classes. And then you try and imitate classes. And then in C# you have classes, and then you have instance of classes that are objects. In Kotlin, you have objects and classes. So this is how you would implement a singleton in Kotlin. So the return type in Kotlin by default is unit. So this is a function now that takes another function. And if I were to say, for instance, this function takes 2 parameters and then put these parameters as x and y, then I could pass in, for instance, higher order. And then here I would pass in my lambda syntax. So I've got x plus y. Now, we have a few conventions also in Kotlin similar to Groovy. If the last parameter to a function is another function, I can exclude it from the brackets. So here you can see that I have a hint, and I say move lambda outside of parentheses, and I have my function outside of parentheses. This can now become multi-line as well, right? You can write it on multiple lines if you like. And this is what I was talking about in terms of Kotlin is very extensible as functions as part of the language as opposed to the surface area of the language. So async, this in our implementation of async, this is actually called async. So instead of calling it higher order, we actually have a function called async, and yet it looks nicely as part of the language. Okay, this is part of coroutines library that we have. Okay, that's Kotlin. That's as short as I can make it in the small amount of time that we have. Okay, so now let's see some of the things that I've been talking about in the slides. So we're going to start with JavaScript, because who doesn't love JavaScript? Seriously, that's a real question. Who doesn't love JavaScript? Excellent. So, got sample. So the idea with Kotlin is, this doesn't work when there's a projector connected. The idea with Kotlin is essentially that you write Kotlin code, and then that outputs to JavaScript. That simple, right? It transpiles to JavaScript. It transpiles to very readable JavaScript. You can target different module types. You can target ColleenJs. You can target AMD. You can target whatever type of module system that you're using so that it's interoperable with that type of module. So here you can see that, for example, I create a data class. A data class is basically a POCO or a POJO, right? Where it has the difference is that it's got the getters and the setter automatically. It's got the toString. It's got the clone. It's got the hash code. All of that. You don't need to write that manually. It's already there because I've added the data modifier to it. So I've got a data customer class. I have a function that logs some output. I have another one that creates an instance of a class. Notice that we have no new in Kotlin. It's just the name of the type. And it's not like JavaScript that if it's uppercase, it's going to be a constructor. If it's lowercase, it's not. This is an actual type. You can do DOM interaction, and this is all with completion. So you can see that I have BG color, and that gives me the DOM interaction. And all of this, basically, I'm going to compile, and this is going to output a file which is called sample.js, right? This is the output of the file, okay? And this is the thing that you would ship with your application. CotllinJS, sample.js, and another file called CotllinJS, which you never open. It's kind of like jQuery. It's just there. Okay? So you never open this one. You just minimize it, and it's there. You ship this in your application, and then if you go to your HTML, you can see that basically I have a script that's being included here, which is CotllinJS, and then the script itself, and I can click on the browser and run this, and you can basically see that it does everything that I was asking it to do. Right? And all of this is Kotlin source code. So I didn't have to write a single line of JavaScript. Okay? Now this is nice. It's like, okay, cool, it's great for a demo, but what could I do in real life with this? Well, there's a lot you can do in real life. And what I'm going to do is show you one thing that we have, which is, let's go over to temp. What do you mean there's no directory? I'm in temp, yes? Yes, okay. Cool. So now I could do, for example, create React Kotlin app ABC. Now, are you familiar with create React app? So we've got the same, which is called create React Kotlin app, which essentially creates a React app for you, except instead of JavaScript or TypeScript, it's all Kotlin. Okay? So you can see that it's working. There you go. And then it says do cd ABC and then do yarn start. So we'll do yarn start, and then that should essentially throw the browser at me, and you will see the default application for Create React come up. Wait for it. Is that beautiful or what? Okay. We have a yet to be announced product that is completely written in CotllinJS. So it's in production. We've been using it for a few years, and because people often ask us, like, is the whole Kotlin targeting JavaScript for real? Yes, it's completely for real. We're very serious about it, and we've got skin in the game, as they say. Or should I say, we've got compiled JavaScript in the game. Bad joke. Never mind. So, if you don't like JavaScript, and you think that TypeScript is too verbose, and you love Kotlin, this is what you need. Okay? Now let's move on to the next one, which is Kotlin Native. So with Kotlin Native, I'm going to show you a few things that are going to impress you seriously. So let's go back to temp, and I'm going to make this presentation, so it's going to be much bigger. Okay, so AB temp. Okay, so I'm going to show you my Vim skills. I'm not just an IDE guy. Now, print line, hello, this is native. Okay, be quiet, no comments. Right, so now what I would do is Kotlin native. So I've got in my directory, I have tools, I have Kotlin native, and then we've got bin, and then here I've got my compiler, and then I would just do d.kt. And this compiles. Now, remember when I said this is still in beta? One of the things that we're improving is the compiler speed, which is really good because, first of all, it's very useful for you when you're developing applications. Second of all, I don't have to completely spend 10 seconds talking utter bullshit while this compiles. So what this has generated now is, if we do a lsla, you see that it's created a file called program.kexe. Now, what is program.kexe? First and foremost, it's why developers are really bad at naming things, because that's meant to be Kotlin exe. And when we first launched Kotlin, it was really funny how everyone would replace the C with a K. Then it just became very annoying after the third or fourth time. Second of all, we are on Mac. On Mac, there is no such thing as an exe. So let's make this much more friendlier to Mac, which is basically we'll just drop the extension. And if you don't have color coding in Mac, you don't know if something's runnable. You just keep running it until it runs. You don't look at this X over here. That just means don't look. So if I run program, you see it immediately comes back, right? There's no JVM startup time. There's nothing. It's basically compiled natively to that platform. And you have cross-compilation. All of those things are available. So that's very, very cool, right? But again, it's kind of like a little sample. What can I do beyond this? If we want people to be able to adopt the language, they need to be able to leverage what's existing on the ecosystem. And for Kotlin Native, as I mentioned, we have all of the C ecosystem available. So if I go to my Kotlin Native, Kotlin Anywhere, and then we do native, and we open this up. If there is a library that exists, it's first and foremost going to be in C. Isn't that right? Yes. So anything you could think of is available in C. This is curl. Have you heard of curl? Right? It's a library to, as well. It's a command line utility. There's also libcurl, which is allowing you to, what curl uses under the covers, to do HTTP requests and so forth. So what I'm doing, if you go to actual the browser and you say libcurl sample HTTP, let's go and see what we have here. Simple example. Let's say of get. Libcurl source code. Oh, okay. Example libcurl get request. Right? So you can see if curl set op, do some perform, and then do cleanup, etc. Okay? It's showing you how to use this in C. So how do I use that in Kotlin? Exactly the same way. Right? Exactly the same way. I follow the exact API instructions that I have in C, and I would essentially write the same thing in Kotlin. So you see that I create an instance of curl. I do easy init. If it's not null, then I do set op, I do perform, and then I do cleanup. Now, where is this coming from? This is a header file that is generated for me by Kotlin. There's a binary called cinterop, which can also be part of your build process. So if we click on Gradle, we use Gradle for Kotlin native builds. You can see that I have my cinterop section, and one of them is libcurl, and I'm defining a project file. And in this case, I'm defining a project file called libcurldef. So if we go to source, you can see that I've got a folder called file called libcurldef. And this is essentially saying, take these specific headers for libcurl and generate for me the Kotlin headers. This gets then compiled in. I have full completion. I have navigation to it. And I'm continuing to write Kotlin code, essentially. Okay? Any questions? Yes? So the question is if it's faster than C. No, it's not. Not yet. Well, first and foremost, because maybe you just don't like C. Yes? I mean, people say, why would I use Kotlin over Java? Maybe because you like it more as a language. A lot of people would disagree with that statement because Java is actually quite performant after the startup. Yeah, but the question is, if it's not faster than C, why would I ever use Kotlin, right? Okay, and I'll say to you the same thing as I just said. It's about the language and what it enables, right? So Kotlin now allows you to target multiple platforms. If you want to share code bases, if you want to leverage that, you can use Kotlin and then target multiple platforms, one of them being native. If you do not like C or C++ as a language, you want a language that is a little bit higher level, you can use Kotlin. These are the reasons. If performance is critical for you right now, don't even look at Kotlin native because we're not there yet. Okay? But it's exactly the same reason. Why would I use Kotlin over Java or over Scala if the language delivers the value that it does that you need? If you like it as a language, if you feel that overall it delivers certain value to you, that's the reason you would use it. And first and foremost, if you can actually justify that from a business perspective. Any other questions? No? Okay. So the next part is scripting. And scripting is quite cool because scripting allows me to do hosting as well. So here, if we go to the script host, you can see that basically I have a file that essentially is creating an instance of a class which is our script host, and then it's loading a file that's being passed into it, and then it's executing that file. So in this case, it's executing a file called sample.kts, which if we go to, you see that there's no main block. It's just top-down Kotlin code. The only difference is that the extension is KTS, right? So now, before, because there's a command line compiler in Kotlin as well. Kotlin C is the command line compiler. And then if you just if you run it without a parameter, it will go into a REPL for you. But if you run it with a parameter, it will compile that code for you on the JVM. If you put S, it will run the script. And a script doesn't need an initialization entry point like a program main. It's just top-down scripting. In fact, there's a new project which is called Cache, yes, with a K, which is, guess, a Kotlin bash. Cool, isn't it? No? No? Okay. What? I don't know. I'm not in the marketing department of these people naming these things. Why create a bash replacement? Did you ask that from MyZSH as well? Okay. Well, there's a reason for it. You use it, right? Okay. So the reason is that you basically get to program in Kotlin as opposed to programming in bash script, right? Also, it's the guy that did TestNG, Cedric, and he's got a lot of free time on his hands, so that's also another reason. So here, what I can do is basically run this application, and what it's essentially going to do is it's going to run the script host. It's going to load the file, run it, execute the output, because I'm saying to execute the output, and then it's going to give me the result of it. So you can see at the bottom, it's saying to me success, value evaluation, everything was successful. if I were to enter, for example, some value in the script file that is invalid, and I run it, then in this case, it's going to give me an error. Right? It's going to say failure, and it's going to point exactly to where that is. And this comes in very, very useful when you can start to combine one of the beautiful features that we have in Kotlin, which is DSLs. Right? Are you all familiar with DSLs? Right? DSL is a domain-specific language, which means that it's a language specific to a particular domain. And that's how I explain myself. I just switch words around. So with DSLs, we often think of DSLs as like, oh, I'm just going to create a DSL around HTML. Oh, I'm going to create a DSL around build script. No, you can create a DSL around your business needs. You can create a DSL, a language around your taxing. You can create a DSL around your, I don't know, if you're in the transport business, how I can transfer from one place to another. To give you an example, Kotlin is actually very, very simple to do this. And in fact, I showed you one of the features that allows this. So if we were to do Kotlin ABC, you can see that basically when I wrote async here, that starts to act like a DSL. So if I were to do, for example, transportation, and then I would say origin equals Krakow airport, destination equals somewhere. And then, for example, here, now I could just do Alt-Enter, create function, a higher order function, and you can see that it starts to work for me. And I'm doing DSL. I'm doing domain. I'm doing DDD, which is domain DSL-driven design, right? So here it says, okay, so what do I take? A function? Well, what is this? This is a function, and then I've got an origin, I've got a destination. Who? How could I get access to that? Well, imagine if I had a class which was called location, and then that had a property which was called origin of type string, and a property destination of type string. Let's initialize those. I'll do var, and then here also initialize those. I could pass in a location, but then this would have to be prefixed as a lambda. So I would have to do something like x, and then here x, origin, etc. Now in Kotlin, if the only parameter to a lambda, if there's a single parameter to a lambda, you can replace that with it. So instead of doing that, I could do it origin and it destination, which is kind of nice, but it's just not there, right? Because now it looks ugly with the it. Could I just have this? Yes, you can, because in Kotlin, you can have extension functions, right? And what is a higher order function? It's a function that takes another function. Can I pass in an extension function to Kotlin? Yes, I can. And that's called a lambda with receiver. So instead of passing in a location, what I do is pass in an extension function to location, and automatically I've got my DSL. Right? So this allows you to create these DSLs and then combine that with scripting, and opens up a wonderful world of possibilities for you. And last but not least, just want to show you what we were talking about before with the multi-platform. In Kotlin, you can create a new multi-platform project and say, I can target JVM, I can target JavaScript, Android, iOS, etc. And then you end up in a situation where you have, for example, here, you see that I have common code, I have JavaScript code, I have macOS, I have JVM, etc. So in the common code, I have class sample, class and object platform, and then I have a function here, and I have a property here. And you see that there's a little A here. If I click on this, Alt-Enter, it says go to actual declarations, and then you can see that based on the platform, I have different implementations. So now I have the actual for, in this case would be, or wherever I was. I was in macOS main. So if I go, for example, to the JS main, you can see that I have the JS. If I go to macOS, you can see that I have native, and from here I can also navigate back up. So you now have this structure where you have common code, and then you have platform-specific code, and if you have things that need to be shared across the different platforms, then you can just go ahead and share that without having to worry about repeating any of the code. Okay? Any questions? Nothing. Is it just so mind-blowing that you're like, this is just so awesome, I just got to go home and play with this? No?
Can you
Oh God. So, if you want to learn more, where you can go? Where can you go? Where can you go? You can go to kotlinlang.org, right? And we have a whole bunch of different ways that you can learn about Kotlin. If you click on Learn, click on Try Online, or, you know what, you could just go to play.kotlinlang.org. And that's the best place, because you've got the playground, which means that here you can basically write code and run it in the browser. Okay? Just as you like. Then you can go to Hands-On, which now this is what we're working on. So you can, for example, building web applications with React and ColleenJs, which takes you step by step on how to create different types of applications. Then you have the examples, which is, if you're familiar with Go by example, this is basically Kotlin by example. So it's the format where it shows you small little snippets of how things work. And all of this is interactive, right? You can actually run each of these little code boxes, and you can modify the entries and see how it gives you an error. And if you're wondering, no, you cannot mine Bitcoins here. And then you also have the koans, which is an interactive way to either do koans online, or you can actually download the koans inside IntelliJ IDEA and basically run through exercises where it will tell you to fill in this placeholder, run this unit test, and figure out how it is. I would also publicize KotlinConf and say, hey, you can also come to KotlinConf, which is taking place in December, but it's sold out, so you can't. But there'll be a live streaming of it online. Sign up to the live streaming. Okay, then we're done. If there's no questions, I will see. Yes? Through Objective-C. No, I mean you can interop with Objective-C, or you can interop with Swift. But I believe that we do support generics. I believe we do. I couldn't answer that. I would have to find out for you, because I don't do the Swift part, really. Any other questions? Yes? It will be shipped when it's ready. I mean, we were giving that answer is when will Kotlin be released, and it worked well for us because we never failed to say it's going to be released here and then it wasn't. But really, I mean, right now what we're working mostly on in terms of native is performance and tooling. Those are the main areas that we're working on. And the feedback around the memory model, because some people, as I said, aren't too happy with the idea of, blowing up at runtime in terms of accessing read-write. Okay, well then if there's no other... Yes?
Maybe one more question regarding the generics in Kotlin, because in Java there is a thing called type erasure. So can I have construct generics objects in Kotlin using the reflection?
Not like the way you could... So the question is if I can create objects using reflection in Kotlin with generic types, yes? Not the way that you can do it in C#, no. So Kotlin we have, because the JVM, as you mentioned, has type erasure. In Kotlin, we do allow reification of certain types. And the way that we do that is because in Kotlin, we have the concept of an inline function. So anytime you have an inline function, you could take a function, and the majority of the functions in the standard library are inline. And inline basically is a sophisticated way of saying it's copy-paste. So because we're inlining, if you take a function that is inlined, you can add the modifier reified to the type parameter, and then you can query on the type, but you still cannot create an instance of it like you could with C#, which is wonderful, but it's not possible in Kotlin. I'm going to say, well, if there's no other question, and someone will again raise their hand, so I'm not going to say that. Are there any more questions? No. Okay, so if you don't have any more questions, if you want to reach me, I'll be in the bar. No, H. Hariri or H. Hariri or hadi@jetbrains.com. And I hope to see you soon in the other room for the most depressing talk ever. Thank you.